Combination. How do we use it? What is it? Combination determines the number of possible arrangements where order does not matter. Why? Helps in matching patterns. Interesting fact, rhinoceros horns are made from a protein called keratin, the same substance that fingernails and hair are made of. Now, let's take a look at the definition of combination. Let S be a set of n elements, and let 1 less than or equal to r less than or equal to n. The combination of r elements of S is a subset of S that contains r distinct elements. What does that even mean? Well, we will put that into action so we can find out. Next we have the theorem on the number of combinations. The number of combinations of r elements that can be obtained from a set of n elements is n choose r is equal to n factorial all over the quantity of n minus r factorial times r factorial, where we have 1 less than or equal to r less than or equal to n. Now, one cool fact about combination is that we can use it to create this table. How does this table look familiar? That is correct. It is the Pascal's triangle. So we can use combination to create the Pascal's triangle, since order does not matter. Which leads us to the binomial theorem. Let's go! That's cool. Now, let's put this into action by taking a look at this example. Let's say we have a 3-digit PIN, whether it's for our ATM card or password for our phone. Now, let's find out how many options there are. Using only 1-digit numbers that cannot repeat, we have 10 options for the first number, 9 options for the second number, and 8 options for the third number. To figure out how many outcomes we have, we multiply these numbers, and 10 times 9 times 8 is 720, and this is without replacement. Using factorials, we can say this is 10 factorial over 7 factorial, which is the same as 10 factorial all over the quantity of 10 minus 3 factorial, and that is the formula for n permutations of r. Now, what happens if we move these options around? We could have 10 times 8 times 9, 9 times 10 times 8, 9 times 8 times 10, 8 times 10 times 9, and finally 8 times 9 times 10. So we have 6 or 3 factorial outcomes for this set. Now, for combination, order does not matter. That means that all of these options are considered the same. Since they are the same, we have to take them out. To find out how many outcomes we have with combination, we write down the total of permutations, which is 10 factorial over 7 factorial, or if you prefer, 720, and divide it by the number of outcomes that repeat, which is 3 factorial in this case. And 10 factorial all over 7 factorial times 3 factorial is the same as 10 factorial all over the quantity of 10 minus 3 factorial times 3 factorial, which is the combination formula. Using this method, the combination formula is also equal to n permutations of r divided by r factorial. Now, let's take a look at the examples we're going to discuss in today's video. Let's take a closer look at example 1. Now, let's read the steps. Step 1. What is n? The object. Step 2. What is r? The position. Step 3. Use the formula. Step 4. Follow order of operations. Now, let's read the question. Evaluate 5 choose 2. Now, let's write down the formula for combinations, which is n choose r is equal to n factorial all over the quantity of n minus r factorial times r factorial, where n is the number of objects and r is the number of positions. In this case, n is equal to 5 and r is equal to 2. So let's substitute 5 for each n and 2 for each r. So now we have 5 factorial all over the quantity of 5 minus 2 factorial times 2 factorial, and 5 minus 2 is 3. So now we have 5 factorial all over 3 factorial times 3 factorial. Now, let's get rid of all those factorials. So now we have 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1 times 2 times 1. Let's simplify. The 4 and the 2 cancel, which leaves us 2 on top. And the 3's cancel, and all the 2's and 1's cancel. So we are left with 5 times 2 on top, which is 10. Now, let's bring back the pin example so we can do it another way. So we only have a 2-digit code because of the 2 and 5 choose 2. And we start with 5 because of the 5 and 5 choose 2. Now we go down to 4 because that is the next number below 5. And 5 times 4 is 20. And that represents the number of objects when order matters. But here, order does not matter. So how many other options do you think we have? That is correct, 1. The other option is 4 times 5. So we have 2 in total. Now we have to divide the total by the number of options. So 20 divided by 2 factorial, which is 20 divided by 2, which is 10. Cool, we got the same answer. You can choose which one is best. That is example 1. Let's move on to example 2. Now, let's read the question. Evaluate 3 choose 3. Now, let's write down the formula for combinations, which is n choose r is equal to n factorial all over the quantity of n minus r factorial times r factorial, where n is the number of objects and r is the number of positions. In this case, n is equal to 3, and r is equal to 3. So let's substitute 3 for each n, and 3 for each r. So now we have 3 factorial all over the quantity of 3 minus 3 factorial times 3 factorial. And 3 minus 3 is 0. So now we have 3 factorial all over 0 factorial times 3 factorial. Now, let's get rid of those factorials. So we have 3 times 2 times 1 all over 1 times 3 times 2 times 1. Remember, 0 factorial is 1. Let's simplify. All the 3's and 2's and 1's cancel, so we are left with 1. Now, let's bring back the pin example so we can do it another way. So we have a 3-digit code because of the 3 on the right and 3 choose 3. And we start with 3 because of the 3 on the left and 3 choose 3. Now, we go down to 2 because that is the next number below 2. And the next number is 1. And 3 times 2 times 1 is 6. And that represents the number of objects when order matters. But here, order does not matter. So how many other options do we think we have? That is correct, 5. The other options are 3 times 1 times 2, 2 times 3 times 1, 2 times 1 times 3, 1 times 3 times 2, and finally 1 times 2 times 3. So we have 6 in total. Now we have to divide the total by the number of options. So 6 over 3 factorial, which is 6 over 6, which is 1. Cool, we got the same answer. You can choose which one is best. That is example 2. Now it is your turn. So go ahead and pause the video here so you can take your time to answer this question, and I'll show you the result in 3, 2, and 1. Did you get it correct? Fantastic. If not, there's always tomorrow,